Hello all, we student of ECE department of Gokaraju Rangaraju Institute of Engineering and Technology. We have done a project named Brain Tumor Segmentation using unit comparing with mask RCNN. The main objective of our project is to build an actual detector using unit which will point out the location of the tumor on MRI images for greater accuracy comparing with mask RCNN. What is brain tumor? A brain tumor is an abnormal grouping of cells in the brain. Tumors are complex. There are a lot of variations in sizes and location of tumors. This makes it really hard to complete understanding of tumors. Medical image data obtained from various biomedical tools which use different image techniques like X-ray, CT scans, MRI, etc. helps doctors to find abnormalities in the internal structure. The automated systems would be able to detect the tumor in MRI and would be able to pinpoint the exact location of the tumor.
So image segmentation is a division of an object into regions. So it creates the pixel-wise mask for each object in the image. There are two types of an image segmentation, that is semantic segmentation and instant segmentation. Semantic segmentation is nothing but objects of same class are represented by the same color. And instant segmentation is nothing but different objects of the same class have assigned of in different instances. In mask RCNN model uses instant segmentation and unit model uses semantic segmentation.
Mask RCNN model is a popular deep learning network in the computer vision field. It is used for instant segmentation. A fully convolutional neural network is added to the faster RCNN model to generate masks for each object. So methods like faster RCNN, fast RCNN, and RCNN are used for bounding box object detection, whereas mask RCNN is for object detection and mask generation. It means mask RCNN detects object, draws boundary box, and applies mask on object.
Proposed model. Proposed model is based on unit architecture. Unit architecture is a type of convolutional neural network used for classification, localization, and segmentation. Unit is designed for semantic segmentation. Its architecture can be broadly thought of as an encoder networks followed by a decoder network.
This is the unit architecture. In this, the first half of the unit is encoder part and the second half is the decoder part. Encoder part is also called as contracting path and the decoder part is called expansive path. In encoder part, an input image is taken and two 3x3 convolutions are applied over it, and each convolution is followed by a ReLU and batch normalization. Then a 2x2 max pooling operation is applied to reduce the spatial dimensions. Again, at each downsampling step, we double the number of feature channels while we cut in half the spatial dimensions. And the next is the decoder part. In this, every step in the expansive path consists of an upsampling of the feature map followed by a 2x2 transpose convolution, which halves the number of feature channels. We also have a concatenation with the corresponding feature map from the contracting path. At the final layer, a 1x1 convolution is used to map the channels to the desired number of classes.
For a given MRI image with the original mask, the unit output and the mask RCNN output are as shown. The unit model outputs are more accurate than the mask RCNN output. We can see that for some images, the mask RCNN output predicted incorrectly, and for some MRI images, it does not predict the tumor. The approach versus accuracy and the approach versus loss graph for unit model are as shown. As the number of approaches increases, the accuracy increased and the loss decreased. We can see that at the end of 30 approaches, the training accuracy is 99.7% and the validation accuracy is approximately 99.5%. Next. If we see the approach versus loss graph of mass carcinogen, as we increase the number of approaches, the loss decreased. And for the 15 approach, we can see that the training loss is nearly 0.5%. If we compare the performance of mass carcinogen and unit models, for mass carcinogen model, we have took the 200 training images and 60 validation images. And for unit model, 2,451 training images and 613 validation images. For mass carcinogen model, we got an accuracy of 96.79%, and for the unit model, 99.51%. We can see that the very few training images we got a good accuracy for mass carcinogen, but for only just 200 images, the mass carcinogen took large amount of training time. Unit took less training time than the mass carcinogen model and gave an accurate results.
By comparing the performance of the above model, we can conclude that unit model more accurate than the mass carcinogen model. Thank you.